Welcome back to the Cosmic Curiosity. If you absolutely love to explore new worlds and keep up with all the latest cosmos news, you are definitely in the right place. And hey, before we get started, if you wouldn't mind taking a second to like, share, and subscribe to the channel, it really tells the YouTube algorithm to boost our content so we can keep bringing you the greatest, most fascinating stargazing videos out there. It's a gorgeous universe, and we want to explore it with you. Okay, so let's dive right into today's explainer. I want you to imagine the sheer tension in a NASA control room. You're tracking a spacecraft, right? One that has been reliably beaming data back to Earth for over a decade. As part of its totally normal routine, it swings behind a massive planet, which blocks its line of sight to our communication antennas. You're watching the clock, just waiting for it to reemerge on the other side. But the clock ticks past the expected time. Then a minute passed, then an hour, and suddenly you realize you're getting nothing but dead air. For anyone who loves exploring the cosmos, this is quite literally the ultimate cliffhanger. Today, we're unpacking the mystery and the absolutely incredible legacy of NASA's MAVEN spacecraft, a veteran explorer that slipped behind the red planet and just never came back online. So the big question, what killed the MAVEN spacecraft? Now, MAVEN, which, by the way, stands for Mars Atmosphere and Volatile Evolution, was definitely not some rookie probe. Not at all. This was a battle-tested 11-year veteran of deep space. For over a decade, it was our eyes and ears in the Martian atmosphere. And then it just vanished, silently. It left behind this incredibly complex forensic puzzle for scientists back here on Earth to try and piece together. So let's break down the exact sequence of events that led to the loss of this really remarkable piece of technology. Let's walk through how this whole tragedy actually unfolded. MAVEN successfully entered Mars orbit way back in September of 2014, and for years, it operated pretty much flawlessly. But fast forward to December 6, 2025. MAVEN swings behind Mars during what was supposed to be a completely standard regular orbit, nothing special about it. But when it was supposed to pop back out, NASA's Deep Space Network, which is this massive international network of giant radio antennas we use to talk to our spacecraft, heard absolutely nothing. Dead silence. Naturally, this triggered a massive response. By February of the following year, NASA actually convened a dedicated anomaly review board just to figure out what the heck happened. And sadly, finally, on June 3rd, they had to make the heartbreaking announcement. MAVEN was officially declared unrecoverable. The mission was over.
All right, moving on to Section 1, investigating the fatal anomaly.
Think about it. How do you even begin to investigate a crime scene that's over 100 million miles away, orbiting an entirely different planet? Well, you have to rely on these tiny, brief, little fragments of telemetry data that the Deep Space Network managed to catch right as the anomaly was happening. And what the review board discovered was basically a cascading failure, a textbook three-step chain reaction. Step 1, the data showed that as MAVEN was emerging from behind Mars, it was suddenly experiencing an unusually high rotation rate. Basically, it was spinning way, way faster than it was supposed to, which actually threw off its orbital trajectory. And because of this violent, unexpected spin, we hit Step 2. The spacecraft's batteries started to drain incredibly fast. It was burning through power it just literally couldn't afford to lose, which, as you can guess, directly leads to Step 3. Total power failure in the communication system. Without power, it simply couldn't phone home to Earth, rendering the whole spacecraft totally unrecoverable. You know, when a machine like this dies, it's so easy for us to just look at the raw data and the cold, unfeeling hardware. But behind every single successful spacecraft is a team of intensely dedicated humans. Shannon Curry, who is MAVEN's principal investigator, actually likened the end of this mission to the loss of a loved one. And I think that really hits the nail on the head. MAVEN wasn't just a robot to them. To the scientific community, it was a dedicated explorer. It was a steadfast partner in unraveling the mysteries of the cosmos. Its sudden absence is profoundly felt by literally everyone who worked on it.
Which brings us to Section 2, a decade of discoveries.
Rather than just dwelling on its tragic end, we really need to look at what this machine achieved while it was alive. We're shifting gears from the cause of death to a bit of a celebration of a truly monumental scientific legacy. MAVEN gave us a decade of uninterrupted, groundbreaking discoveries. Take the number 6.6, for example. That number perfectly captures MAVEN's insane work ethic. Every single Earth day for over 10 years, MAVEN completed roughly 6.6 orbits around the red planet. Day in, day out, plunging down through the upper atmosphere and swinging right back out into space, tirelessly collecting data. That relentless, everyday repetition is exactly what allowed it to completely rewrite our understanding of Martian history.
Because of all those orbits, MAVEN provided the very first direct observations of a multi-million-year process that's been steadily stripping Mars of its atmosphere. Seriously, think about that for a second. Before MAVEN, we just had theories, educated guesses, but after MAVEN, we had hard, undeniable proof. It acted as the absolute best observer anywhere in the solar system for watching exactly how a planet slowly bleeds its protective atmosphere out into the dark, freezing void of space. Next up, Section 3, the mystery of sputtering. Okay, so one of the most absolutely fascinating breakthroughs of the entire mission was solving a huge mystery regarding the harsh Martian climate. It's a process known as sputtering. Now, I know sputtering sounds a bit technical, but conceptually, it's actually incredibly dramatic. Basically, sputtering is a process where the solar wind, which is this continuous, powerful stream of charged particles blasted out by our sun, slams right into the upper atmosphere of Mars. When it hits, it physically flings those atmospheric particles completely out into deep space. Imagine a relentless, high-speed wind blowing against a fragile sandcastle, green by green, year after year, just slowly eroding the whole thing away. MAVEN found the first direct evidence of this happening. It finally explains how Mars transitioned from a world that actually could have flourished like Earth into the dry, seemingly dead planet we're looking at today. And the crazy thing is, the discoveries didn't even stop there. Beyond sputtering, MAVEN's data helped researchers identify a totally new phenomenon, where Mars's surprisingly thin magnetic shield actually defends the planet against solar radiation way better than we previously assumed. It also detected multiple different types of auroras literally dancing across the Martian sky. Oh, and it revealed that when the solar wind calms down, the Martian magnetosphere can actually balloon outward by thousands of miles. MAVEN basically painted this incredibly dynamic, highly complex picture of how Mars interacts with the sun. It proved that Mars isn't just a dead rock, it's a really active, highly reactive environment. Let's look at Section 4, Legacy for Future Astronauts. Now, why does all of this matter to us? Well, everything we've just talked about isn't just abstract science history. These discoveries are absolutely 100% prerequisites for our future. Understanding the Mars atmosphere and its magnetic shield is utterly crucial before we can ever even think about sending human astronauts to the Red Planet. Humans are incredibly fragile, right? Solar radiation is deadly. We absolutely cannot simply drop astronauts onto the surface of Mars without fully, deeply understanding how the planet's environment reacts to the harsh weather of our solar system. So yeah, MAVEN might be dead. It might be spinning silently in the dark right now. But the 11 years of data it basically sacrificed itself to collect, that data is going to serve as the foundational safety manual for human survival on Mars. So I want to leave you with this thought. How will MAVEN's invisible map of solar radiation ultimately protect the first humans to step foot on Mars? Decades from now, when those very first astronauts look up into the Martian sky, totally protected from deadly solar winds by habitats that were engineered using MAVEN's data, they are going to owe their lives, in part, to a silent, spinning little probe that worked itself to death just trying to understand a new world. It's a gorgeous, fascinating reminder that every single step we take out into the cosmos is built on the backs of the robotic explorers that paved the way. I really hope this explainer on MAVEN's legacy sparked some curiosity for you today about the truly beautiful engineering and science happening right now, millions of miles above our heads. Again, if you enjoyed this gorgeous journey into the cosmos, please like, share, and subscribe to The Cosmic Curiosity. Until next time, stay curious and keep looking up.